Hello guys, welcome back to my channel. Meson African Motives. Still working on variation for mathematics O level. So in this case we shall continue on partial variation, that is working still on NGM book 4. From this time we shall be focusing on exercise 9A. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Meson African Motives. Okay, so like I said, we shall be focusing on partial variation. I think from the previous variations, we managed to work with joint variation, direct variation, inverse variation, if you still remember from the classes that we had. So if you are new guys and you didn't manage to watch these classes, make sure that you watch them so that you'll be able to understand. Just on the playlist, you just go to the playlist on variation for each topic that you want to revise. Just go to the playlist. You will see the playlist for each and every topic, okay, that is there, so you can manage to work on direct, inverse and joint variation. All right, so that's what we managed to work on. So in this platform, like I said, we shall be working on partial variation. So if you manage also to watch the video of joint variation, we managed to discuss something about this type of variation, which is partial variation, in a shorter version, where I was referring to sum of two parts. It's a variation that actually refers to sum of two parts. So when you are referring to sum of two parts, you are referring to two given variables that are going to be connected together but adding. So in this case, you are given like this. It can be h plus kb, or you can be given something like this: a is equivalent to hb plus kc, like this. Still, these two are adding. So the way that you connect now the two are variation. So in this case, there is no condition like a varies with. You are not going to have that. It's straight a is equal to, where these h and k are constants. So h and k are constants. All right, then we have got a, b and c. These are variables. All right, these are the variables that you'll be given. All right, so how can I actually write this? Where is it actually coming from? That is the question now. Where are we actually having this from? That is what we are actually asking ourselves. All right, when you are given a variation in word, where you are given that a is partly constant, like this, a is partly constant. The part that you are given like this, that partly constant, it means it's just a constant that you are given, where you are just given a constant such as h. All right, that is just a is partly constant, but it can be and partly varies. I want you to see the difference here. Partly varies as b. I want you to see the difference here. Partly constant is just a constant alone, and partly varies as b. What are you sensing here? There is a constant that is going to be affecting together with b as b. So this is the one that you're given as a is equal to the constant h plus, which is the end here, kb. That is how you're going to write this one. A is partly constant and partly varies as. Okay, then someone might wonder, what about this one? How can we have this condition? This is a condition where you are now given as a varies partly as b and partly as C. All right. When you are given this now, or A is partly constant, now is not going to work. Why? Because we are given a constant with B, so it's partly as B, partly as C. So that is what you're going to have. Varies partly, just like this part. Partly varies as, which is the same. A varies, you have started with the varies, so we're going to have partly as the letter that is affected by the constant, so it's B, and partly as C, so it must be partly as. That is how you connect. All right, so the same thing that you had when you are working with direct variation, you had to introduce you have to find the values of the constants. In actual sense, there you only had one constant. There was only a constant K, only one, but you had to find this constant so that you find a relationship between the letters. So it's the same thing, but here you're going to find the values of H and the values of K. These are the two constants that you have. So you must find the value of H and also find the value of what? The value of K, so that you're going to have a relationship between A and B, or a relationship between A, B, and C. You have to find the value of H and K. Since these are two unknown values, definitely there is no way to solve this than to apply the simultaneous equations. So you have to be very, very good in solving simultaneous equations, because you're working with two unknown values. So whenever you are working with two unknown values, it means you have to apply the simultaneous equations. I don't know the method that you're going to apply there, but it must be simultaneous, whether you're applying substitution or you're applying this, but all those should be under simultaneous equations. All right, so I want us to cross-check the questions that we are given from this exercise. Like I was mentioning, that we are going to focus on exercise 9E. All right, we are given the question number 1 on exercise 9E, where X is partly constant and partly varies as Y. So let's take note, guys. I want us to take note here from the information that we have. X is partly constant, so we are back to that condition where we just have a constant. All right, and partly varies as Y, so which means you're going to have a constant with a Y like that. Take note, the end there is just to add. All right, so which means let us write this down. Okay, let us write this down. So number 1, you're going to have X is equal to, all right, we said partly constant, that is H, so it's going to be H plus, which is end there, and that's a plus. Partly varies as it's going to be a constant as the letter as Y, constant and Y, so it's going to be plus KY. All right, now you are given when Y is equal to 2, X is equal to 30, when Y is, so take note, guys, this is complete information. When Y is 2, X is equal to, these two are working together, and that is another information. When Y is equal to 6, X is equal, this is another information which works together. Okay, so find the relationship between X and Y. Find the relationship between X and Y. So the relationship is still the same that connects X and Y without these letters H and K. So what are you going to do? You have to substitute Y is equal to 2, X is equal to 30. All right, X is equal to 30. Remember, 30 is equal to H plus Y, which is equal to 2. We said Y is 2, so it's going to be K2, which is going to be 2K like this. All right, we move on, and another information, when Y is equal to 6, X is equal to 50, so X is equal to 50 when Y is equal to what? When Y is equal to 6, so is equal to H plus, in place of Y you substitute 6, so it's 6K. So how can I now find this relationship of X and Y, which means I have to solve for X, I have to solve for H and K. So how can I solve for H and K, guys? These are now simultaneous equations, where you have equation 1 and equation 2. So as you can see here, h and h are actually the same, so you can actually use elimination method. You can eliminate h there because they're actually the same. So I'm going to subtract equation 2 from equation 1, so it's 30 minus 50. Okay, equation 2 from equation 1, 30 minus 50 minus 20, which is equal to h minus h, that's a 0, 2 minus 6, which is minus 4k. All right, divide by negative 4 so that I can find the value of k. Divided by negative 4, so these two can cancel, so I'm going to have k, which is equal to negative, and negative can cancel, 4 into 20, which is 5. So I now have the value of k. All right, so with this value of k, I'm going to substitute into n of these. I can choose to substitute into this equation or this one, just n of your choice. Okay, so I'm going to choose the first equation where we have 30 is equal to h plus 2k. All right, so let's substitute the value of k, which is 5. In this case, we've got 5 here, so it's going to be 30 is equal to h plus 2 by 5. So it's like this, 2 times 5. You substitute the value of k, so 30 is equal to h plus 2 times 5, which is 10. Then transpose to this side, is going to be 30 minus 10, all right, which is 20 actually. Okay, so h is equal to 20. So you have the value of h, and here you have the value of k. So you're going to substitute now into this equation so that you are now going to be left with x and y. So that is the relationship. Okay, so let's substitute. Remember, h is equal to 20, so in place of h, so therefore x is equal to, in place of h, you've got 20 plus ky, of which our k is 5, so it's going to be plus 5y, like this. All right, so that is the relationship between x and y, or the relation between x and y, or the equation which connects x and which connects x and y. So that is how you determine that equation. Then b, find x when y is equal to 3. So what are you going to do? It's a continuation on b. Okay, so since we know that x is equal to 20 plus 5y, like this, you are simply going to substitute, because you are given the value of y is 3 and you want to find the value of x. So x is equal to, using your substitution, is going to be 20 plus 5 into the value of y, which you are given in this case, which is what? Which is 3. Okay, so take note here, your y is 3. So what are you going to have? 20 plus normal multiplication, 5 times 3, which is 15. Then you can add, which is going to give us 35. So x is equal to 35. So as you can see that when you are working with partial variation, it's still one and the same thing with what you were doing with joint direct variation. The only difference is that you're working with sum of two parts and you're going to have two constants. You'll be working with the two constants. That is the difference that you can note. And how to connect also the variables is very, very important, because if you are to cross check on this one, on number 6, the other questions, they're actually one and the same thing, but this one I want to focus with it because it has something that is different from what we had from the previous question. Here it's a varies partly as b and partly as the square root of b. So take note, we've got partly as b. So okay, let's see what you're going to have. A is equal to varies partly as b, so it's going to be partly as b, a constant followed by a letter b. Take note, it's no longer partly if it is partly constant, it's just going to be a constant only, but here it's as b, so it's a constant as b. All right, and another one, partly as the square root of b, the same b, but this time is the square root of b with a constant, so it's going to be another constant with the square root of b, like this. All right, it's not partly constant, it's partly varies partly as, so it's going to be a constant as b, a constant as the square root of b. All right, so the question is, we are given this information when b is equal to 22, when b is equal to 4, a is equal to 22, and when b is equal to 9, a is equal to, so this is full information and also another full information. So the question is, find a when b is equal to 25. How can we determine the value of a when b is equal to 25 without the relationship? There is no way without the relationship. So you need the relationship first between a and b, the variables that you're given. Okay, so how can I find the relationship? Let's substitute and find the values of what? H and k using this information. When you are given b, you're also given a, so you can substitute. In place of a is 22, so 22 is equal to b. Your b is 4. Okay, so take note, this is h, which is 4h, plus here is going to be the square root of 4. Okay, and square root of 4 is what? Is 2, so it's going to be 2k. Take note. We move on. When b is equal to 9, a is 42, so a 42 in place of a, b 9, so it's going to be 9h plus square root of 9. Here we're going to have square root of 9 here, which is 3k. All right, so that is what you're going to have. So these are the two equations that you want to solve. So as you can see, now it's difficult for us to eliminate because these two are not the same, these two are not the same. But I can make either k and h to be the same. Here I've got 2 and 3, so I can just multiply the first equation by 3, the second equation by 2 here, so that these two can be the same. So you're going to multiply everything actually. So it's 3 by 22, which is 66, and 3 by 4, which is 12h, plus 3 by 2, that's 6k. All right, then you're done with 3. You move on to 2 by 42, that's 84 from your calculator, and 2 by 9, which is 18h, plus 2 by 3, which is 6k. Actually, you're not supposed to use your calculator because most of these questions are from paper 1. Okay, so we have got our equation 1 and our equation 2 in a simplified manner, and these two are the same. K and k are the same, so I can eliminate k by subtracting the second equation from the first equation. So I have to subtract 66 minus 84 is simply 84 minus 66. Then you're going to take the sign of the bigger number. You're going to obtain 18, not 14, this is 18. Okay, then you take the sign of bigger number, so it's minus 18, which is equal to 12 minus 18, which is 8 minus, it's just 18 minus 12, okay, which is 6, so it's going to be minus 6h. The 6 minus 6, that's a 0. Okay, so we are going to simultaneous equations, guys, remember simultaneous equations. Okay, so divide by negative 6 by negative 6, so your h is going to be 3. All right, so I have got the value of h. I need to find k, so I can substitute into any of these equations, but I can just use this simpler one. I can just choose from these equations. Okay, so I've got 22, which is equal to 4h plus 2k. Okay, and it's raining, guys, it's raining so much, and I don't know how I'm gonna end this. Okay, anyways, let's try to end this. Our h is 3, so let's substitute. In place of h, we've got 3. All right, so 22 is equal to 4 times 3, that's 12 plus 2k. All right, transpose this. 22 minus 12, which is something like 10. Okay, so you're going to obtain 10, which is equal to 2k. Divide by 2 by 2. All right, so your k is going to be 5. Okay, so I'm just going to rush up until I finish this. So we have got the value of k, the value of h. So the relationship is going to be, this is our relationship that we are going to substitute here. So a is equal to, in place of h, we've got 3, so it's 3b. All right, that's 3b plus k, or k here, k square root of b, so it's going to be 5 square root of b, like this. All right, so this is the relationship between a and b. So it's, take note, this is 3b plus 5 square root of b. Okay, so the question is, find a when b is equal to 25. Find the value of a when b is equal to 25. So you have to substitute in place of b. So your a is going to be 3 times, this is 3 times, in place of b we are given 25 plus 5 square root of b, which is square root of 25. All right, let's see what you're going to have. 3 times 25, that's 25 times 3, which is 75, plus 5 times square root of 25, which is 5. All right, so you're going to have 75 plus 5 times 5, which is 25. Okay, then 75 plus 25, which is 100. So the value of A is going to be 100 in this case. So that's how they ask these questions, and what you're supposed to actually answer, the way that you're supposed to answer these questions. Okay, so guys, as you can see, you've got a lot of questions that we can be asked when you are working with partial variation. In fact, when you're working with variations, partial variation, you are working with joint variation, you are working with inverse variation, you're working with this type of variation, whatever that you're working with. So there's a need for you to revise as many questions as possible. So as you can see, guys, that we are done with this variation, which is the last part of variation, which is partial variation. So we shall be having questions now from past exam papers relating to the areas that we have focused on and we have done from the variation and other topics as well. So not to miss these classes, make sure that you become part of the family, Meson African Motives, as we shall be working on question papers and revisions, and also textbooks from NGM Book 3 and NGM Book 4 for Mathematics O level. So that's it, guys, from Meson African Motives. Till we meet again.